Welcome. Here we got a super simple Java Spring Boot CRUD API so that we can demonstrate Spring Boot caching. So here is our entity that we'll be working with. It is a cat. We've got the entity annotation. We're using just an H2 database right now. So we got the ID, we have a name, breed, color, age, and Boolean is the cat overweight or not. So let's flip to our controller. Before I forget, when we're using caching, place the enable caching annotation over your main class. All right, so back to our controller. We've just got 1, 2, 3, 4, 5 endpoints just for creating, reading, updating, deleting. Well, let's look at this one first. So find all cats. So the problem is, say we have a database with 1 million cats. It's going to be an expensive operation just getting all cats, hitting that endpoint. So we want to be able to cache that. So we place this cacheable annotation over this method. It can be in the controller layer. The annotation could be in the service layer. I believe it could even be on the repository method. Yeah, well, I'm just using this repository. I don't want to override all the default methods that are built in with JPA repository. But if you are kind of doing a custom implementation for your repository layer, I think you could place the annotations over those methods too. Anyway, so we're going to hit this cats endpoint, localhost 8080/API/v1/cats to get all cats. What this is going to do is call cat service, find all cats. So here's how we are mocking an expensive operation. We are forcing this thread to sleep for 3 seconds and then returning cat repository.find all. And like I mentioned, JPA repository built in, pretty nice. So let's spin this up. I am skipping quite a few things here actually because currently the DB is empty. I'm going to have to post a cat first, but let's do that. All right, we've got it all set up over here in Postman. So we'll try to get all cats right now. Ignore this previous response, but get all cats. Notice that it took 3.27 seconds. That's because it hit the thread.sleep and returned us nothing. 200, okay, just haven't implemented any error handling. Very simple. So let's create a cat. Good. Cat's got an ID of 1. Name is Jasper. So let's get all cats again. Notice we have that cache annotation over the class. So why did it take 3 seconds to load again? Why did it not take 0.1 seconds and return us another empty list? That's because our post mapping has this annotation, cache evict. This combats the, sorry, can't think right now. Anyway, if we were to post a cat after already hitting the get all cats endpoint and receiving nothing, if we didn't have this cache evict annotation over the post endpoint to reset the cache, we could call the get all cats endpoint all day and we're just going to get an empty list. Users could post 500 cats meanwhile in the backend or in the database, and we're not going to receive anything with this get all cats endpoint because we're pulling from the cache, which is out of sync with the source of truth, the database. So when something transactional, I don't know that word well enough to explain, but I believe that's the right word. When something transactional happens in the database, like altering information, post, delete, put, patch, for a simple application like this, again, pretty new with Spring Boot caching, we're going to place cache evict over that method so that we reset the cache so that our database and our HTTP calls requests are synced up. We're actually getting the truth real time. We are not pulling from a cache that's outdated. So we have cache evict over this update cat method, put mapping, and also the delete mapping for deleting cats. So let's demonstrate some of this. Watch. That cat with the ID of 1 is still in the database, so this should be a very quick response. Boom, 10 milliseconds. Extremely quick, 4 milliseconds. But if we create another cat, we want to see both of those cats now. This should take 3+ seconds. So we are getting real-time, accurate data as it is in the database. And if we hit it again, 5 milliseconds. So assuming nothing has changed in the database, it can be very quick. So this would be great for working with lots of data that doesn't get updated very often. It's mostly read data. So get by ID, first time hitting it, kind of a cold start, so 3+ seconds. Okay, and fast again, 4 milliseconds. So here's the drawback. I think we just created a third cat. Get cat by ID is taking 3+ seconds. So that may be a drawback. That cat wasn't updated. It's the same exact cat, ID number 1. If you get advanced with it, then I'm sure you can implement the ability to not update everything in the cache, just select things. So let's delete cat number 1. Okay, so now we only have cats with IDs 2 and 3 in the database. Let's get all cats again and see what we get. There we go. Let's update cat number 2. Okay, let's get all cats again. As expected, we get the updated cat. Let's delete cat number 2. Success. Let's try to get cat number 2. Let's see what happens. It's gonna take 3+ seconds and we'll get a 500 because no error handling. Okay. Get all cats, 3+ seconds. Sweet. Why does it look like that now? That was weird. Yeah. Back to the code. This is available on GitHub. I believe it's Kieran Mueller, no spaces. Very simple hello world caching application to get started, take a look around, and get comfortable with it.